Hey there, GCSE Edexcel psychology students. Let's jump right into things today. We are unpacking what is essentially a fascinating detective story about our genes and our mental health. If you're prepping for your exams, you are in exactly the right place because this explainer is going to give you everything you need to absolutely master the classic Caspi et al. 2003 study. We are going to uncover exactly how our biology interacts with the unpredictable events of our lives.
You know, it's a huge question. Why do stressful experiences lead to depression in some people, but seem to completely bounce off others? Life can be incredibly tough, but not everyone who faces hardship, trauma, or massive stress develops depression. This was the exact mystery that Caspi and his team set out to solve. They were essentially hunting for a biological smoking gun that could explain these individual differences.
So here is our game plan for today. We're going to break down the study exactly as you need it for your exam, following the SOTA structure. That's background and aim, sample, procedure, results, and conclusions, before wrapping the whole thing up with a grave evaluation framework. Let's get to it.
All right, Section 1, Background and Aim. We've known for a long time that stress can trigger depression, but a major piece of the puzzle was missing. Like, why might person A develop severe depression after losing their job, while person B, facing that exact same job loss, recovers pretty quickly?
To crack this, Caspi's team leaned on the diathesis stress model. Honestly, this theory is the ultimate mashup of the classic nature versus nurture debate. It suggests that complex behaviors, like depression, don't just happen in a vacuum, they're caused by an interaction. You need a genetic vulnerability, which is the diathesis, or nature part, combined with an environmental trigger, which is the stress, or nurture part. Caspi wanted to know, if someone has a biological vulnerability, does it actually combine with real-world life stress to cause depression?
And that brings us to our prime biological suspect, the 5-HT gene. This little gene controls the amount of serotonin available in your brain. Now, as you probably remember from your biopsychology classes, serotonin is the neurotransmitter that essentially controls our mood. High levels generally mean happiness, while low levels are directly linked to depression. In fact, SSRI antidepressants specifically target serotonin to improve a patient's mood. So researchers zeroed in on this 5-HT gene because, well, people actually have different versions of it. Specifically, if you have short S alleles, your serotonin efficiency is much lower compared to someone with long L alleles.
Moving right along to Section 2, Sample and Procedure. Tracking human development over time requires a seriously wild amount of dedication.
Just look at this timeline from the Dunedin Multidisciplinary Health and Development Study. The researchers didn't even have to recruit a fresh batch of participants. They utilized an existing cohort. They checked in on these exact same individuals repeatedly at age 3, then 9, 15, 21, and all the way up to age 26. They literally tracked these people's lives for 23 years.
So who exactly were we looking at? The sample consisted of 847 Caucasian, non-Maori participants. Caspi's team took this massive group and divided them into 3 specific categories based completely on their 5-HT-TLPR genotype. Group 1, which was about 17% of the sample, or 147 people, had 2 short alleles. Group 2, the biggest chunk at 51%, with 435 people, had 1 short and 1 long allele. And finally, Group 3, making up 31% with 265 people, had 2 long alleles. Keep in mind, those short alleles are the ones we just linked to lower serotonin efficiency.
Fast forward to when everyone hits age 26. The researchers rolled out a highly standardized procedure to measure both the nurture and the nature outcomes. Step 1 was measuring the stress. They used a life history calendar to record 14 different stressful events. We're talking employment issues, financial crises, health scares, relationship breakups, things that happened strictly between their 21st and 26th birthdays. Then step 2, measure the depression. They assessed depressive symptoms using the diagnostic interview schedule. Plus, to make sure the data was incredibly solid, 96% of the participants also had an informant, like a close friend or family member, fill out a questionnaire about the participants' depressive symptoms over the past year.
Okay, Section 3, Results. This is the moment of truth. Let's dive into the data and see if those gene variations actually made a difference when life got tough.
First things first, before we even look at depression, we have to look at the baseline stress exposure. Across the whole sample, 30% experienced 0 stressful events, while 15% experienced 4 or more. But here is the absolute kicker regarding this data. There were 0 differences across the 3 genetic groups in terms of how much stress they actually experienced. This is vital. It proves the 5-HTT gene doesn't just make you prone to putting yourself in stressful situations. The environmental trigger was identical across the board. It was their biological reaction to that stress that differed.
The contrast in the outcomes is just staggering. For folks carrying the short S allele, stress predicted a 17% rate of major depression episodes and a 3% rate of suicide attempts. Crazy enough, childhood maltreatment directly predicted adult depression solely for this short S allele group. Now contrast that with the long L allele carriers. Having that long version of the gene significantly reduced the impact of stressful life events. It acted almost like a biological armor, protecting them against life stressors and entirely buffering the effects of childhood maltreatment. And there's this brilliant little methodological bonus hiding in the results. Stressful life events predicted the informant reports of depression among those short allele carriers, meaning their friends and family actually noticed the depressed behavior in real life. This perfectly rules out self-report bias. The participants weren't just exaggerating or stuck in their own heads. Their depression was a measurable, observable reality confirmed by the people who knew them best.
All right, Section 4. Conclusions. Let's tie all this data together and solve the mystery we started with.
The big takeaway you absolutely need to lock down for your exam is that the 5-HTT gene does in fact interact with life events to predict depression. But the key here is that the long allele acts as a moderator. As the researchers concluded, those carrying the L allele were less likely to develop depression. The gene essentially buffered these individuals against life's worst stressors. This gives us undeniable, concrete support for the diathesis stress model. It really does take both the genetic vulnerability and the environmental stressor to trigger the behavior.
Finally, Section 5, Evaluation. Because in psychology, no study is flawless, right? You'll need to critically evaluate this research using the GRAVE framework.
Let's systematically walk through this. Starting with generalizability, a huge plus is the massive sample size of 847 individuals, which gives the study great population validity. But a major downside is that they were all Caucasian, non-Maori from one specific area in New Zealand, so it definitely lacks cultural generalizability. People in other cultures might handle stress completely differently. Moving to reliability, the natural experiment used a highly standardized procedure with the exact same questionnaires, making it super easy to replicate. However, that life event calendar relies on participants remembering things from up to 5 years ago, and let's face it, human memory is notoriously unreliable. For validity, self-report questionnaires always carry the risk of social desirability bias. People might downplay how depressed they feel so they don't make a fuss. And lastly, ethics. Asking people to vividly recall highly traumatic life events just to fill out a questionnaire is risky. It could absolutely cause psychological harm or distress to the participants. Now the A in GRAVE, application, really deserves its own moment in the spotlight. Why does a study from 2003 matter to us today? It matters because it provides hard, scientific evidence for the diathesis stress model. By proving that depression is partly caused by the 5-HTT gene's control over serotonin release, it fully supports the medical application of using SSRI antidepressants to treat depression. If we know the biological mechanism that low serotonin efficiency interacts with stress to cause depression, we can confidently use medication to artificially boost those serotonin levels and help patients feel better. Which brings us to one massive question to leave you with. If our genes moderate our reaction to stress, how might this change the way we treat and understand mental health in the future? Like, if we can literally map out who is genetically vulnerable before the stress even hits, could we prevent depression entirely by changing their environment early on? It's a pretty profound thought about the dance between nature and nurture. Keep that dynamic in mind as you study. Best of luck with your GCSE Edexcel psychology revision, and thanks for joining me on this explainer.